All right, welcome back. This is another factoring video on how to factor polynomials. We'll start with a review of type 1 and type 2 and type 3 factoring. Type 1 factoring is when we factor out a GCF. So see if you remember, the GCF is the greatest common factor. I look for what both terms have in common. They both can be divisible by 5. They both can be divisible by an x. So that's our greatest common factor. And we put our leftovers in parentheses. We divide everything by 5x, which would give us 2x squared plus 1. The difference of perfect squares, this was a pattern that we recognized, the sum and difference pattern. When we first see the difference, subtraction of two perfect squares, we start by building two parentheses. And all we're doing is taking the square root of the first term and writing it twice. We're taking the square root of the last term. And then we put a plus sign and a minus sign. Remember that you can always double check your work by multiplying the polynomials together to make sure you get the same thing you started with. In our last video, we learned type 3 factoring, and that's when we have a trinomial with a leading coefficient of 1, which is what we have here. It's in the form of x squared plus bx plus c. So we have that example here, and we learned that we put a little x box. We take the last term and put it in the top. We take the coefficient of the middle term and put it in the bottom. And then we ask ourselves a math puzzle. We say, what two numbers multiply to negative 12, but could add up to 1? So I think it's going to be a combination of 3 and 4. It has to be negative when I multiply these two numbers together, so one of them has to have the minus sign, and it also has to be negative when we add them up. So I think if we put the negative sign on the 4, 3 times negative 4 is negative 12. But when I add up 3 and negative 4, I'll get a negative 1. So we do that little X box just to help organize our thinking. And just like in the difference of perfect squares in the example 2, we're going to set up two different sets of parentheses. We're going to take the square root of the first term and write it twice. And then we take these side pieces from our X box. The first thing I wrote down was 3, so that's a positive 3. And the second thing I wrote down was a negative 4, so that's a minus 4 in my binomial. Again, go ahead and double distribute or FOIL to see that you've gotten back what you started with. That's your review of type 1, 2, and 3 factoring. And we're going to move on to the next type of factoring, which is called factor by grouping. This is my favorite one to do. In factor by grouping, you have to have 4 terms. So we worked on like a binomial, we worked on a trinomial, now this one has 4 terms. And our terms are all in descending order. We're going to split the polynomial into 2 sets of terms, and then we're going to factor each separately by using type 1 factoring, pulling out a GCF, writing the leftovers. We'll find a common polynomial, and that will be able to be our factor. So here, if we take a look at this example, it says factor x times x minus 5 plus 3 times x minus 5. Look at both of these as their own term. What do they each have in common? Well, if you look inside those parentheses, you'll see it. They each have an x minus 5. That is actually its greatest common factor. So we're going to start by writing that first. Remember, we always put our GCF first. And now we're going to write what's left over. Well, I already wrote x minus 5, so x is left over. I already wrote x minus 5, so 3 is left over. What should I put in the center there? Oh, that plus sign. And that's a part of factor by grouping. So let's practice this part, and then we can put it all together. Go ahead and take a look at examples A, B, C. I'll do A with you, then I'll ask you to pause the video and try B and C, and then check back. So the greatest common factor is in those parentheses. So I'm going to write that first. Oops. finish the parenthesis, and then put the leftovers afterwards. So I have a 5x squared, and then I have a plus 3. Okay, you try. You pause the video, factor out what you can, and write your leftovers. All right, if you went ahead and practiced that, for letter B, our greatest common factor is going to be y minus 5. And what we have left over is 7y minus 3. For letter C, our greatest common factor is x minus 8. And let's see what we have left over here. We have an 11x and we have a minus sign. Well, that can't be. I have to have a number behind the minus sign. Remember that if you don't see a value, there's probably a little 1 in there. So this was a coefficient of negative 1. So I'm going to go ahead and put that right there in my leftovers. Okay, if you've got that together, then we're going to just add the first piece. We actually kind of just practiced the last piece of this, but we want to go ahead and put both pieces together. And the first piece is double checking that you have 4 terms and that they're written in decreasing order. Then we split the 4 terms in half. So let's take a look. I've got n cubed plus 6n. That's my first 2 terms, plus 5n plus 30. So I'm going to go ahead and slice this 4-term polynomial into 2 pieces. So let's just look at the first piece. Can you find the greatest common factor? Our greatest common factor here is n to the 2nd power. Let's go ahead and write leftovers in parentheses. I'll have an n plus 6. Great, let's leave that to be, and let's take a look at the second half of our work. What's the greatest common factor between 5n plus 30? Well, the greatest common factor there is 5. I'm going to write plus 5 as the greatest common factor and put my leftovers. And I did plus because there was that plus sign there. And positive 5 was my greatest common factor. And what's left over? Let's see, if we divide everything by 5, we'll get n plus 6. It's like magic. Look at those parentheses. Do you have the same thing? Yes, just like that. It's like magic. We split our 4-term polynomial into 2 pieces. We pulled out greatest common factors and looked at our leftovers. And our leftovers are now the new greatest common factor. So just like in our previous slide, we're going to go ahead and put that n plus 6 in front and write our leftovers after that. What's left over is that n squared and the plus 5. See why it was so important to put that plus sign there for the plus 5? Because we carry it all the way through to there. And you've just factored by grouping. Let's see if we can do the same thing on letter B. We're going to first slice it into 2 pieces. And then we're going to look only at the first group and see if we have a greatest common factor. In this case, our m squared is the greatest common factor. And we go ahead and divide by that greatest common factor, and we'll get m plus 7. So now when I do the GCF and stuff of my second set, I'm hoping to find m plus 7 in my parentheses. So let's see what we can do. So I've got negative 2m minus 14. So we're going to pretend that this first half doesn't exist anymore. Look at your leading coefficient. Is it positive or negative? That's right, it's negative. You always want your leading coefficient to be positive. So our GCF here is going to be a negative, and it will be a negative 2. And look what happens. If we pull out a negative 2 and divide everything by negative 2, we're going to end up with m. Negative 14 divided by negative 2 is a positive 7. And now we have the same thing in parentheses. If you had pulled out let's say we pulled out a positive 2, then our leftovers would be negative m minus 7, and they're supposed to match. And so you can test it out and see, oh, did I really pull out the GCF here? If I didn't, then I'm not going to get a match. I need that match. So we're going to go ahead and erase all that and go back to our initial problem. So now we do have the same thing in our parentheses. So we're going to write that in front. That's the GCF. And now we put our leftovers in parentheses. M squared minus 2. Let's take a look at letter C. Slice it in half. If you think you can try it yourself, go ahead and pause the video, try it, and then check back in. But if you want more guidance, let's go ahead and talk through it. Our GCF for the first chunk of our polynomial here is 9x squared, with leftovers being x plus 1. In our second chunk of our polynomial here, I'm going to pull out -7, because when I divide by -7, I'm going to get a positive x, and I'm going to get a positive 1 there. If I only pulled out +7, then my terms would not match in parentheses. So they do. That's my greatest common factor. We're going to write that in front, and we're going to put the leftovers in the back. Of course, whenever you're done with all of these problems, you always want to double check that there's nothing left over in your parentheses, in your leftovers, that could be factored more. Like I shouldn't see in here the difference of perfect squares. It should be already factored. And if it's not, then we want to go ahead and do a little bit more factoring for that. All right, you've got a bunch here to try. Go ahead and give those a try. Pause the video, do your best work, and then come back and check in. Notice that A and B are set up as already been partially factored. So they already show you what's in parentheses as being a match. So that's your greatest common factor, and your leftovers are written behind it. Okay, go ahead and pause the video and check back in. All right, when you take a look at B, you'll get y minus 2 times 3y squared plus 5. And when we move on to C, this is where we put it all together. We've got to slice it in half, find that greatest common factor of the front, greatest common factor of the back. And you'll see in parentheses, you've got the greatest common factor of it all. So our greatest common factor is x plus 3, leftovers x squared plus 5. Letter D was interesting because when you sliced it in half, you've got x squared as the greatest common factor of the first part, but really nothing as the greatest common factor of this second part. So if there's nothing to pull out, you remember you can always pull out a 1, and that's what I've done here. So we've got x plus 1, and leftovers x squared plus 1. On letter E, we only had variables to work with, but you could still do the same thing. Our GCF is y plus 1, leftovers y plus x. And on letter F, I don't know if you tried it. If you split it down the center, you will notice that there's nothing in common in the first two terms between x cubed minus 6. So if you look at it closely, you say, oh, I have to rewrite it in decreasing order. That was one of the rules, one of the stipulations for doing this. So once you do that, then you can go ahead and slice it and then pull out your GCF and write your leftovers. Your GCF of the whole thing is x minus 3, and you get x squared plus 2. And that is type 4 factoring. Check in on the next video for type 5 factoring. This is factoring a trinomial when our leading coefficient is not 1, because we've already learned what to do when it is 1. We'll have to learn what to do when it's not 1.